Service provider architecture. Would you agree with me that the rate of technological change on planet Earth has now reached ludicrous speed? Seriously, over the last 20 years, it seems like it's done something like this where it's just going wham, and some new collaboration method or technology comes out every other month that literally changes the way that we do life here. Right? It's no longer just about how computers store files or back up their data, all that, the normal IT stuff. I mean, look around, take a walk. How many people, when you're walking, are going to be glued to their cell phone? I'd say 20, 30% are, Facebooking or Skyping or watching a movie as they're walking on this device. It's like, ignore the trees and everything else that you're here to walk for. We've got to look at our collaborative device. So where does this leave the service provider in all of it? They're evolving as well. As a matter of fact, Cisco has created a whole model for it they call an IP Next Generation Network Service Provider, or NGN. That's what we're here in this nugget to unpack, is what does that mean when you hear IP NGN Service Provider? What does that architecture look like? Where is it going? What are the different kinds of service providers? All this and more in this nugget. Just about every nugget in this series will start with a slide that looks like this. It says, do I know this already? These questions really encapsulate the key elements or concepts that I try to convey in this nugget. So if you look at those questions and you go, oh, I got that, no problem, then I would say pause and move on to the next nugget in the series. Otherwise, let's get started. I'm sure at some point in life we've all seen a television program that shows the planet Earth from outer space, right? And it's usually accompanied with, instrumental music or just silence, and you take a moment and breathe it in. It's so peaceful, right? As it zooms in closer to planet Earth, you start seeing all of the chaos that's going around on this planet. Is the man with the cell phone on his steering wheel watching Netflix careens off the road, causing all kinds of... So anyway, you know what I mean. The closer you get to something, the more complex and chaotic it feels. And it's the same way with the service provider network. So I wanted to take a step back, enough steps back, that we could see it from a really big picture format, and then we'll slowly step in piece by piece and unpack these elements. First off, from this view, the 10,000 foot view that we're looking at here, you have aggregation nodes and a service provider core, the two major elements of this. Now, the aggregation nodes are essentially the locations in the world where the service provider has invested and built a presence. I use that word in particular because it's typically called a point of presence. Think about when you think of a telephone carrier, most people have heard of a central office, right? Essentially the telephone carrier, whoever you have, CenturyLink, Quest, US West, those are actually all the same companies because it's all we have out here on the West Coast. But nonetheless, these carriers have said, okay, we see an area where there are thousands of subscribers. So from a business model perspective, we will build a facility which maybe costs us $2 million to build, but we know that we'll get at least 800 of those people to sign up, paying $40 a month. So they're kind of, this is the business of the service provider, right? They decide where these point of presence locations goes, which is why the metropolitan areas are usually the first to receive these services, and why all these service providers are scrambling to run fiber optic cable as fast as they can to the highly populated area, because it's just good business, right? So the aggregation nodes allow you to reach your customer through a variety of methods. Now, up here, I'm not even going to touch much of this in this series, but you've got cellular technology, right, where you can bridge out and reach people's mobile devices. Down here at the residential area, you have things like cable modems, DSL, and I'm not just saying that's residential. I mean, they really, cable and DSL carriers have been going after businesses as well, releasing cable business internet services or DSL internet services, but you have many different methods. You also have, for instance, PON, passive optical networking. Now, typically you're talking about a business in this case to where you have fiber optic cable run directly to the facility and terminated there, to where you really have the sky is the limit on bandwidth. It's just how much do you want to pay the carrier to get from your facility. So a lot of different areas that they can reach. So this is all bundled into a POP. Right? And they have a whole series of equipment inside of there. We'll unpack that more as we go. These are usually connected together on a sonnet fiber ring that runs under a city or under a metropolitan area, even branching out through a variety of geographical locations. When you're talking fiber optic cable, you're talking about light. And the beauty of light is that you can regenerate it, repeat it, without degradation of signals like we have on typical copper cable. So really, you can run fiber optic cable hundreds or thousands of miles. There are even fiber optic runs going through the ocean now. Which is just, I go back to how I started this whole series. It's amazing how fast all this technology has been coming out, right? But all of it will eventually come back to the service router core. So big picture, in the service router core, we have the aggregation points that bring in all these different nodes. I kind of use the same terminology. So essentially, it is an aggregation of all the different aggregation nodes coming into that core, and maybe that core reaches out to other areas. Maybe this is where we uplink to other internet service providers that this service provider has a carrier agreement with and have brought in links from them. Maybe this service provider core uplinks to other service provider cores. Essentially, this carrier maybe is a national carrier. So maybe this represents one major region, Arizona, and then it links up here to California and links over here to Nevada and all these different locations where the carrier would be, and you would see the same model replicated there. So as we move from my artistic interpretation of a service provider into the official Cisco NGN service provider model, all we do is take one baby step closer to planet Earth. Remember my analogy, going from really big picture, because one layer of detail is now revealed. Same picture as what we saw on the previous slide, but now we see another layer of detail revealed. This represents the POP, the facility that the service provider has invested in to reach customers. Now, how is it reaching them? Well, depending on the service provider, you may have cellular technology, which I'm not even going to touch that right now, but it's something that we may talk about a little bit more later. But primarily, almost 100% of what we're going to focus on is all right here. Cable, DSL, and passive optical networks, or PON, or it's essentially fiber optic to the doorstep, right? Someday down the road, maybe 50 years from now, maybe more, we will have optical networks everywhere. It'll be commonplace to go to the wall jack or the access box of a home and see an optical cable terminating there. But until we get enough shovels and backhoes to dig up the streets all around the world, we're going to rely on copper cabling technology, which has been around for decades and decades. Cable, DSL, which is already run to a lot of these facilities. So we have the businesses, the residents that's being reached by these technologies and brought in to the POP. This is known as the aggregation node. Now, if we were to break this out, if we were to model this, you would typically see a three-tier model. This is where you'd see your core layer, distribution layer, and then access layer. I don't know if you guys remember the three-tier Cisco hierarchy. I think we talked about in the SPNGN1 series. If not, we'll come back to it. But this is, obviously a very high-level representation of that. But notice we've got multiple aggregation nodes, which would reach other access layer, other neighborhoods that this carrier has paid to reach out to, right? Bringing them all into and feeding them to the core network of the service provider. How do they get there? Through SONET and DWDM. Essentially, we're not going to get into that in all its gory detail in this nugget. Actually, that was part of SPNGN1. Just think of it as a big old redundant fiber optic network where the bandwidth is virtually limited because you're using this DWDM technology, dense wavelength division multiplexing. I mean, think of this. Let me just give you the simple view compared to TDM. Right? TDM, time division multiplexing, something we've been using for decades and decades on T1 lines, E1 lines, essentially carving out little time slots and splicing together multiple channels to allow more bandwidth to be added. That was the most, see, the lines explain it all, right? So time division multiplexing is just sending things at different times so that you can squeeze more onto the wire. Well, all this does is use different wavelengths. Wavelengths of what? Light, my friend. Star Wars, Star Trek. It's all true. It's where we have these different frequencies of light that we can use. And the amazing thing is they haven't even started tapping it yet. They've now figured out 100 gigabit Ethernet over a single frequency of light. Good grief, how much can a fiber optic cable hold? only the future will tell. So virtually limitless bandwidth, and the beauty of DWDM. So again, high level view, right? Sonnet, fiber, that kind of cable is essentially the almost physical layer technology that allows this redundant fiber to be laid. DWDM allows you to run gobs and gobs and gobs of bandwidth over that, so that we don't have to keep trenching up the streets to lay more fiber. We don't have to add more, fiber across the ocean. All of that, you can just add another frequency to the same fiber strand and add gobs and gobs of more bandwidth, right? Okay, so man. Is this exciting or what? It's good. So as we dig deeper, what's in the core? Well, this is what really defines an NGN architecture from Cisco's perspective. What is, let me now answer, what is a next generation network from Cisco's perspective? It's delivering multiple services all over an IP network. Okay, what services? It's the same services Cisco has been preaching for years and years and years: data, voice, and video. When I first got into Cisco back in 2000, I quickly got into voice over IP, and this was when Cisco was running their big AVID campaign, AVVID. It was the architecture for voice, video, and integrated data. This is at 2000, the year, Y2K timeframe. Cisco has this vision of running these three services over a common network, and now it's commonplace. So a next generation service provider is one who takes a SIP server, which is the voice side of things, who takes a video on demand server, that's down here, who takes internet networking and internet access and bundles it all into an IP packet. That's the key. A lot of carriers still today are using different frequencies, for instance, to deliver television, to deliver telephony services. So instead of sending it across the IP network, they'll carve out a different frequency and say, oh yeah, that's your cable TV. Or, oh yeah, that's your analog line. So it's not truly an IP-based system, but that's where Cisco wants people to go. That's what they truly consider a next generation network, is one who does all of that using the IP protocol. Now, with all these models out there, I've got to go practical on you for just a minute. I know, humor me, right? I know you've probably looked at this slide with the picture and gone, okay, no, what are you talking about, Jeremy? You too can be a service provider, and I'm going somewhere with this, right? Now, if you're building this kind of design, you missed your boat, your ship had sailed, but this could have been what you would do back in the day: buy a whole bunch of analog lines maybe coming into your house, set up a little modem bank like this with a T1, which probably would cost thousands of dollars a month back in those days, to connect off to the internet and essentially sell dial-up internet service, and you become a ISP, a service provider, in your home until you max out this home. It gets too hot for you, so you buy a house down the street, and of course you'll have to talk with your HOA to make sure they're okay with you doing this. Run a little conduit through the neighborhood, get everybody in the neighborhood to sign off on the deal or whatever, and you got a second house that you bridge up there, and essentially you're building POPs, right? Points of presence, and your enterprise slowly grows home by home by home. Now, I say that just to say this is kind of the hot button in today's world. You might throw around the word WISP a couple places and see who turns their head, because this is kind of a buzzword, I think, made popular by a company called Ubiquiti. Which is an amazing story in itself. The owner of Ubiquiti actually used to work for Apple in their wireless division, saw an opportunity and built Ubiquiti. Is now a billionaire at 30-something years old. Just went off and bought a hockey team, I think, because that's what you do when you're 30 years old with $1 billion. And essentially this company, anyway, that was a true side tangent. This company, Ubiquiti, sells amazing wireless gears, and they are really pushing this WISP concept, wireless internet service provider. So here's, I feel like I'm about to sell you a marketing campaign, multi-level, Amway or something. But here's the pitch for you, right? Go to your house and go get a little setup from Ubiquiti. And by the way, your DSL provider will probably despise you and ban you for doing this. So maybe buy an optical line or something, so at least they feel like they're getting their money's worth, because you're becoming a competitor by doing this. But then set up a little, Ubiquiti setup in your neighborhood. Sell, on-demand internet access, 30 minutes for $1, and you get a little 5-mile radius with your antennas, and eventually buy another house. You get what I'm talking about here, right? It's still possible. And this is the architecture of a service provider, how they grow. Essentially, you start off with your POP and your core being together, and then as you grow further and further and connecting your sites with optical networking, you now have a service provider. And I do this. I know it sounds trivial, but just to again take it back to the practical, it's not that big a deal. When you think about service provider network, it's like, oh, complexity. And yes, there is a lot of complexity and thought that has to go into it to make sure you do it well and do it right. But at the same time, at the end of the day, it's just one network connected to another. Now let me take that thought that I just gave you and bridge it into this final concept. If you take that idea and run with it and set up a WISP in your own neighborhood, you have become what is called or coined as a local ISP. Essentially, a smaller local area ISP. You haven't really gone outside of your primary location of influence. Maybe it's a city, maybe it's a state, something like that. And you've got your own little set of customers. And to give them internet access, essentially, you've done something. You've got some kind of value add, right? Whether it's a relationship that you bring them. You come in and you say, hey, I'll bring you internet access for $59.99 a month, and I'll also manage your computers and do it, to where you kind of become this all-in-one service provider, or whether it be something where you offer it cheaper because you have low overhead, whatever. Essentially, whatever your little gimmick, your sales thing is, you get some customers. You will need to uplink them to some other ISP, and that will be most likely a regional ISP. So you're the little guy. Let's just say you call it Lollipop Networks. I don't know if there is a Lollipop Networks, but that's what came to me. So that's the name that you call it, and you uplink to. This would be something like a CenturyLink, right? A Sprint, a Cox Communications. It's something that's now regional, to where it's extending multiple states. It's got a large presence, and one of the things I want to make sure I mention here to start filling in some of the terms. Notice we have this protocol now coming into play. Customers should have no idea about it for the most part, but you do. It's the Border Gateway Protocol, where now you've got your own little public blocks of IP addresses that you are allocated from, most likely from the regional ISP, or you've registered for your own block and you have one that's totally independent from somebody else. But that's what you assign your customers, and you then advertise that block out to your regional ISP. Now, this local ISP only has one uplink. So maybe he's just getting started. He doesn't have a big budget, but from a customer perspective, they'll be a little nervous because they're going, well, what if that link goes down? Some of these other guys, have two uplinks to their regional ISPs. So BGP is what allows you to, number one, offer some level of redundancy, because you can advertise your block out multiple different service providers. So Lollipop Networks, in this case, let's just bring a line right here, could advertise their blocks this way and this way. So if this entire link or service provider went down, you end up having alternative paths into that carrier. So that is one advantage, and the second advantage is that you receive all of the different prefixes from the other carriers, meaning you start finding the best routes out of your networks. You don't use a default route anymore, although you could. You can actually get the entire internet routing table from multiple sources and make intelligent routing decisions based on that. Now, this BGP is a routing protocol relationship. Where is this relationship happening? Well, a lot of times it's called a NAP. Essentially, it is a facility where service providers meet together. Oftentimes, it'll be in a data center. For example, here in Arizona, there is IO Data. That is one of the largest data centers that we have here, where they have many different carriers that come together into that facility, and sometimes they will have independent points that, one carrier will say, hey, I'm going to start this up just so we have better peering, and they'll call that a NAP, a network access point, to where they have, multiple redundant switches. Somebody funds the venture, and all these other carriers kind of pay to link into each other, so you just have more efficient and more better connected paths through the internet to each other, right? So regional ISPs eventually link up to national service providers, and these are the behemoths, the giants that you can't really touch unless you get to that regional ISP level, that then provide, international coast-to-coast connectivity, and, usually are very, very expensive connections to link up to. Usually a national service provider does not link to customers directly. They are a carrier of carriers. Does that make sense? So notice this regional guy has its own little residential customers. The local guy have their residential customers. Up here, they are bridging the carriers together. How does that feel? Good? Warm and fuzzy? I hope so. That really, I'm hoping, gives you that big picture view of the architecture of a service provider. I realize that most people that end up working at a service provider started in the corporate world. They started in a business, in an enterprise environment. So the service provider has always been that mysterious cloud, and I hope this has peeled back that cloud PowerPoint image enough for you that you're like, oh, okay, I'm getting how everything is connected. Good. Well, read through those questions one more time, see if they're a little clearer than they were at the beginning. I hope this has been informative for you, and I'd like to thank you for viewing.